Kinetic energy is the energy an object possesses due to its motion. It is one of the fundamental concepts in physics and is described by the following equation. K(mv)(k)(21)mvt, where Ke is the kinetic energy, m is the mass of the object, and v is its velocity. Here's how kinetic energy works and some key points to understand. Dependence on velocity and mass. The kinetic energy of an object is directly proportional to the square of its velocity. This means that doubling the velocity will result in 4 times the kinetic energy, KEV2. The kinetic energy is also directly proportional to the mass of the object. Doubling the mass will double the kinetic energy, KEKE. Scalar quantity. Kinetic energy is a scalar quantity, meaning it has magnitude but no direction. Unlike velocity or acceleration, it doesn't have a specific direction associated with it. The concept of kinetic energy is closely related to the concept of work. When work is done on an object, it can change its kinetic energy. The work-energy theorem states that the work done on an object is equal to the change in its kinetic energy. Energy transfer. Kinetic energy can be transferred between objects. For example, in a collision between 2 objects, kinetic energy can be transferred from one object to another. In the absence of external forces like friction or air resistance, the total mechanical energy of a system, kinetic energy plus potential energy, is conserved. This is known as the conservation of mechanical energy. Maximum kinetic energy. The maximum kinetic energy an object can have is when all its initial potential energy, due to height for example, is completely converted into kinetic energy. This occurs at the lowest point in its motion. The SI unit of kinetic energy is the joule, J. In the formula Ke(12 mv2 Ke(21 mv2), the mass is typically measured in kilograms, kg, and velocity is measured in meters per second, ms. In summary, kinetic energy is the energy associated with the motion of an object. It depends on both the mass and the square of the velocity of the object. Understanding kinetic energy is crucial for analyzing the dynamics of moving objects and is a fundamental concept in classical mechanics.